Yes, good afternoon all. So, this is the second class. How are you feeling? Good? Bought the atlas? We'll be going to each and every country. Sitting here in the class, we'll be having a world tour. Right? Without visa, passport, pending 0 NP. Of course, don't say that, sir, I have paid enough, sir. Okay? In the geography classes, normally we'll be moving the entire world. By the time we complete the entire syllabus, we'll be having such a information like, if any part of the world is given, you will be having some brief knowledge about that particular place. If someone is talking about Spain, if someone is talking about the Greece, or someone is talking about the Scandinavian countries, you will be having some knowledge regarding those countries. What are Scandinavian countries? What are Iberian countries? What are Balkan countries? All these things will be there. Meaning what? Whenever you are talking about geography, it has to be interlinked with the history. History and geography are inseparable. You need to read history with a geographical perspective. You need to know geography with the historical insight. That is the link between the history and geography. Got the point? Now, in the last class, we have given a simple introduction to the universe. Let we discuss something briefly about the universe, and then we'll be coming to the first chapter of our geography called as geomorphology. Right? Let us talk very briefly about the universe again. Since we need to know where we are, just need to know where we are in this solar system. Therefore, we are discussing briefly, and then we will be talking about the geographical aspects like geomorphology. See, this is about the last class, like what is given, like what are the references books and all these things are given. Now let us move directly to the universe. Universe. Yesterday I am talking about one very important and widely accepted theory called as the Big Bang. What is this Big Bang? It is a atom which is the smallest particle which is having infinite mass and energy. What happened? All of a sudden it got exploded. This is what the belief. Why it exploded? What happened before this one? No idea. Even today. Because of this one only, where the people are trying very hard to understand what happened before this time period. Even there are number of questions like, what are the boundaries of our universe? How far it is extended? All these things are unanswered questions, yet they are there in the minds of the people, right? Now it got exploded. It got exploded and keep on expanding. Even today it is expanding. Because of ever expanding nature, we are unable to understand what are the limits, nothing but the boundaries of the universe. Recently what we came to know that one particular galaxy, which is known to be the farthest galaxy, is anywhere between 13.3 to 13.9 billion light years. It is around some billion light years. What is a light year? Just like whenever you are measuring the distance on the surface of the earth, like whenever you want to go to Delhi, to Agra, how much time it takes and what is the distance, you will be expressing in terms of kilometers. On the same lines, in the space, since the space is so expanding and the larger area is there, the measurement of the distance is done with the light years. What is this light year? The distance traveled by the light in 1 year. What is the velocity of the light per 1 second? Let's see this one. Light will be traveling or moving at around some 3 lakh kilometers. Meaning what? If I am giving the number itself, 3 lakh kilometers per second. See the velocity of the light. Second for us is a highly negligible time period. How many seconds will be wasting? But within that 1 second, light is having the capacity to travel about some 3 lakh kilometers. If such a light is allowed to travel for 1 year, how many seconds are there in 1 year? 365 into 24 into 60 into 60 into 3 lakhs. That becomes 1 light year. That becomes just one light year. How many such light years are there? Not 13.3 billion light years, not 13.3 light years, it is 13.3 billion light years. What is billion? How much is billion? Huh? 100 crores? Meaning what? 13.3 into 100 crores into 3 lakh into 24 into 60 into 60. Just see the space. When the space is so extensive, and it is a known galaxy, and beyond that one also, suppose if at all we are here, maybe that is present here. And how much of space is there beyond this one? We don't know. That is what the huge space that is present in our universe. We don't know the boundaries of the space even day. Because of this galaxy, where the astronomers named this one as MACS 0647 JD. This is what the name given for this, the farthest galaxy. This is the known farthest galaxy. These are the different names that are being given by the astronomers, so that if any another new known galaxy is known, then they will be giving 0648 JD. And it will be continuing. Meaning what? Till now, how many such were discovered? 647. Whenever the new one will be discovered, then it will be given as 0648, 0649, 0650. It will be keep on expanding. Got the point? This is what the farthest known galaxy. Then, what happened the moment once the mass of this particular atom got exploded? What has taken birth? Space has taken birth. Time has taken birth. Some of the energy that is present in this atom got converted into the so-called matter, nothing but the dust and the gas particles. And these dust and the gas particles are just like a clouds like this. This is one cloud of dust. This is another cloud of dust. This is another cloud of dust. This cloud of dust technically called as nebula. It is called as nebula. Nebula. What is a group of dust and the gas particle called as? It is called as nebula. What is happening in the nebula? The gas particles and the dust particles are keep on having the mutual attraction, and therefore they are spinning around a common center. When all the dust particles, the gas particles are spinning to a common center, what is happening at the center of the nebula? Because of the nuclear fusion, because all the material is coming to a common center, like take a bucket of water, put some sand particles, spin the water, where you can find the denser mass that is accumulating in the middle of the water, right? Middle of the bucket. On the same lines, whenever the gas, the dust particles, all they are spinning to a common center, the denser particles came towards the center. Because of the mutual attraction, they started collided, and there is a great frictional force, due to which the material got fused, meaning what? Clubbed with one another, giving birth to the new stars. Giving birth to the stars. This is what the star house. How the stars are taking birth? The stars are taking birth in the nebula. Nebula is the place of birth of all the stars. Whatever the stars you are seeing right now, all the stars have taken birth in one or the other nebula. And one our star is our sun. Our sun is also a star. Whenever we say it as a star, what is there in the star? Each and every star is having certain energy. Energy that is fused. Again, the energy cannot be created nor destroyed. Whatever the energy that is there, it is fused in that one particular newborn star. This is what the energy that is fused. Because of the energy that is fused, where it can glow, it can twinkle. How it will be twinkling? The basic form of the energy is the hydrogen. The hydrogen that is present, which is present in the star, because of burning of the hydrogen, where the two hydrogen atoms burn to form the helium, when they are burning, what is released? Tremendous heat energy is released. Because of this one, whenever you are talking about the sun's rays, they are having not only the light but also the heat energy. This is what the energy that is keep on emitting from the star. Imagine that, suppose if this is a star, let me put like this. Suppose if this is a star, each and every star will be having some energy. Since it is formed because of the fusion of the energy, therefore it has turned into a bright material which is called as star. Since it is having energy, keep on burning. Because of burning of the energy, it is glowing. Whenever it is glowing, what it is utilizing? It is utilizing the energy. Whenever you are utilizing the energy continuously, like best example, what is the best example? Whenever you purchase the bike, you will be filling up the petrol tank. And after filling up the petrol tank, what is there in the bike? Energy is there. And you will be keep on moving from place to place. What happens to the energy? It will be utilized. Because of utilizing the energy, keep on exhausting. Whenever it is exhausting, at one point, there will not be any energy. Then again you need to take the vehicle to the petrol station. That is what the common scenario that is happening on the surface. But see this one. When the energy is utilized continuously, every day, every second, when the energy is continuously utilized, what is happening at one day or the other day, just like our vehicles, even the energy get exhausted. The moment once the energy get exhausted, star is having two ways. The star is having two ways to get turned into. The moment once the energy get exhausted, what happened? It cannot glow. Why it is glowing? Why it is twinkling? Because of energy that is present. The moment once the energy that is there in the star get exhausted, what happens? It cannot glow. But see the two ways. One is, in fact, the moment once the energy comes to the exhaustion position, it turns into what is called as, it turns into a red giant star. Meaning what? Massive. It will be keep on increasing in size. When the energy is getting exhausted, it will be expanding in size. The outermost layers gets exfoliated, meaning what? They get removed, and the core remains as, either it can remain as white dwarf, or it can turn into supernova. Every star is having two ways. The moment once the energy get exhausted, it may either turn into white dwarf or it may turn into supernova. What do you mean by supernova? White dwarf we have explained, like it will become larger in size, the outermost layer gets shredded off, and the core will remain as a white color material which is called as white dwarf. If the star is turning into supernova, what do you mean by supernova? Nothing but the star, whenever it is getting the material or energy getting exhausted, it finally explodes. The moment once it explodes, what happens? We can find all the material which is scattered into pieces and pieces, which is called as the star dust. That very star dust will be scattered again in the, what is this one? In the nebula. Suppose if the star, it got exploded like this, it get scattered in the nebula. What is happening in the nebula? All the material is spinning to a common center. This material again spin to a common center, again fuse, again new star takes birth. This is how the recycling is happening. Is it clear? This is what called as the position supernova. But why some of the stars are turning into white dwarf? Some of the stars are turning into supernova. What is the criteria? What is the criteria? It was discovered by very great Indian physicist by name Mr. Chandrasekhar. He has developed a concept called as Chandrasekhar limit. He developed a concept called as the Chandrasekhar limit. What is this Chandrasekhar limit? Even today, every scientist in the entire world is following this concept. Not just in India. It's the concept of the world called as the Chandrasekhar limit. What is this limit? Limit, this is nothing but, suppose this is the star which is getting exhausted its energy. When the energy is getting exhausted, it has to turn either into supernova or white dwarf. When it will be converted into supernova or when it will be converted into white dwarf, provided this particular star's mass, the mass of the star, if it is less than 1.44 times the mass of our sun. If the star which is about to exhaust its energy, if the mass of this particular material is less than 1.44 times the mass of our sun, then it turns into white dwarf. It turns into white dwarf. If the mass of the star which is about to get exhaust its energy, if it is having the energy, mass, which is more than 1.44 of the mass of the sun, such stars turn into supernova. Such stars turns into supernova. This is what the limit discovered by Mr. Chandrasekhar, an Indian origin physicist. And so this limit is called as the Chandrasekhar limit. This is a very important standard that was discovered by Mr. Chandrasekhar. It depends upon the mass of the star, meaning what? All the stars are not of equal mass and equal size. Some of the stars can be massive in size, some of the stars are smaller in size. Say for example, if the star is smaller in size, if the star is smaller in size, what happens? It will be keep on glowing. Whatever the energy that is there, it will be keep on glowing very steadily, very coolly for some billions of years. For some billions of years. Why some billions of years? Because the utility of the energy is at a limited pace. Since it is small star, it will be consuming the energy slowly. Suppose if this is a massive star, big star, the energy consumption for the glow is more. Whenever the energy consumption is more, what happens? It can live for only a few thousands of years. A few thousands are to a maximum of some millions of years. So which star will be having more lifespan? It is the small stars. Luckily, our sun is a small star. Luckily, our sun is a small star. It is believed that the sun has taken birth around some 5 billion years. What is the age of our sun? It is around some 5 billion years. And what is the expected lifespan? The expected lifespan is another 5 to 7 billion years. What is the expected lifespan? Another 5 to 7 billions of years is there for the sun to turn into red giant. And so you need not to worry. You can prepare for your civil services. Okay, enough time is there. Another 5 to 7 billion years means what? So massive time for us, right? And so we can do whatever the job we can do. Fine, it is not going to collapse very quickly. But there is no chance of star remaining forever. You talk about any star, there is no chance of the star remaining forever. Just like we people. Everyone will be taking birth and at one point or the other point they will be dying. The same is the case even with the stars. The lifespan of the star depends upon its size. Size does matter. If at all you are big, it will be dying very quickly. Big means what? It will be glowing very greatly. Within short span, it will be glowing so massively and it will be visible to more distance and finally it will be dying very quickly. Unlike the small stars. They'll be having prolonged lifetime, maybe some billions of years, just like our sun. See, the time period 10 to 12 billions of years means what is a prolonged time period? Is it clear? This is what the massive star and the small star. Now, the moment, imagine that one star has converted into white dwarf. What happens after that white dwarf? What is a white dwarf? Nothing but whenever there is a star, suppose if this is a star, when the energy got exhausted, it has expanded in size and the core remained as it is and all this material got removed from the core. This is the core, the outermost layers are removed. This is what called as the white dwarf. This is the one. This is called as the white dwarf. After some hundreds and thousands of millions of years, even this white dwarf get converted into dark or black dwarf, and it remains as it is. Even today in our galaxy called as Milky Way, 6% of the stars are of the dwarf sized material. They are just present like this. They are not glowing, they are not performing any work, but they are simply revolving to a common center. The moment once they come to a common center, if they get fused, again it will be having a fresh leaf of life. The stars are dying and again rebirthing, they are taking birth again in the nebula. This is how the life cycle of the star is happening. All the material that gets scattered whenever the explosion is there, the scattered material again turn into a spiral one, again it get fused, again to form a new star. That is what is happening. This is about the so-called white dwarf. Now talk about the supernova. Say, imagine that there is a star which is larger than the size of and the mass of our sun. It is more than 1.44 mass, 44 times the mass of our sun. When the star is exhausting its energy, it explodes. The moment once it explodes, the two products will be the outcome. When the supernova happens, there can be two ways where the star can again remain. One is called as the neutron star. One is called as the neutron star. What is the neutron star? Just like what happened in the white dwarf, where the periphery material got removed and the core remained as it is, the nucleus remained as it is. And the same way, when the supernova explosion takes place, all the material explodes, gets scattered. The larger material, the larger remnant, the larger piece of the star is called as the neutron star. It will be remaining. And finally it get converted into what is called as the pulsars. It get converted into pulsar. What is a pulsar? Pulsar is nothing but the neutron star, but the radiation of the energy will be taking place. Like, suppose if this is the neutron star, the radiation of the energy, not in all the directions, but the radiation will be like this. Some of the rays will be moving out. You can see clearly like the rays are coming in one direction. This is called as the pulsar. There are so many such pulsars within our Milky Way. Not only in our Milky Way, in the nearby galaxy called as Andromeda, where again so many pulsars were discovered. Our galaxy is a Milky Way. The nearby other galaxy within the same nebula called as the Andromeda. There is another galaxy called as Andromeda. This is the nearby galaxy. What is that galaxy which is very near to our Milky Way? It is Andromeda. In this Andromeda, there are so many pulsars were discovered. This is the pulsar. There is another fashion of explosion. The moment once it is exploded, if the star's mass is around more than 1.44 the mass of the sun, it turns into neutron star. Imagine this. Suppose the mass of the star is more than 10 times the mass of our sun. More than 10 times the mass of our sun. It's not just 1.44 times, more than 10 times. When such a huge star explodes, what is the output? You will come to see the massive black holes. These are the very interesting features that are there in the space. So many massive black holes are there. In fact, in each and every galaxy, at the center, there is a massive black hole was discovered. Even at the center of our galaxy, what is the name of our galaxy? Milky Way. In the center of our galaxy, there is a massive black hole called as, what is the one? It's called as Sagittarius. Sagittarius, massive black hole. Recently, a few months back, not just 1.5 months to 2 months back, this was photoed, captured. This massive black hole was taken, a pic. The pic is available right now with the humanity. Till this point of time, we have studied about this one. There is a massive black hole at the center of the Milky Way, but in the recent past, just 2.5 months back, what happened? For the first time, the people have taken a snap of this Sagittarius black hole. This is the latest discovery that was there. When there will be a black hole will be there whenever the size of the star, the mass of the star is so massive. The massive stars, whenever they explode, what they will be leaving? They will be leaving the black holes. What is a black hole? Black hole is such a dark space in the space, the dark place of the space where nothing can escape. It is having such a great gravitational pull. Each and every particle is pulled towards its center. We are far away from the black hole, yet we are being pulled. We are at the distance of almost some hundreds of light years, yet the influence of the black hole of Sagittarius is there on our Milky Way, on our solar system. It is being pulled. When it is constantly pulling, at one point or other point will get under the influence and they will be pulled towards its center. The moment once it goes into this one, what happens to that particles which are entering into the black hole, we don't know till now. What we can see is, yes, the material is being pulled towards the black hole. Once it is entering into the black hole, what happens? We don't have the knowledge. Once it falls into the black hole, till now we don't have the knowledge of what happens. It's just like a enter the dragon. The moment once you enter, there is no question of return. The same is the case even with the black hole. Black hole is such a massive material which is having a very great gravitational pull where nothing can escape its pull. Not even light. Even the light is not able to escape the gravitational pull of the black hole. Recently what happened? In the year 2015, in the month of September, the day is called as 14. The day is called as 14. In the year 2015, on the day of 14 September, what the scientific community discovered? They discovered that there are certain gravitational waves. There are certain gravitational waves in the space. See, again, this is the latest development. In the year 2015, the scientific community discovered certain gravitational waves. What are these gravitational waves? It is believed that right from the beginning, like right from the time period of Newton, even the Einstein, all these people, they believed that there might be some waves that are present in the space. This is what the physics experiment, they say that there should be some waves, but till now they didn't discover till 2015. In the year 2015, we discovered certain gravitational waves. For the first time, practically, we have discovered the gravitational waves. What are these gravitational waves? How the gravitational waves takes birth? It is believed that whenever two massive black holes, suppose these are the two massive black holes, whenever they are, since they are spinning, They are spinning and they are pulling all the material towards the center. When two massive black holes comes under the influence of each other, since each is having gravitational pull, therefore they will be attracting each other. Once they get attract each other, they will be coming close and they get fuses up. The moment once they get fuses up, they will be coming close, they circulate to a common center, and finally they get fused. The moment they get fused, enormous energy will be released. From that, you can find the birth of the gravitational waves. This is what the people discovered. This event, the massive two holes that got fused, which are having the mass of, let us see the mass of anywhere between 29 to 36 times the mass of sun. Such a black hole. I am not talking about the star. I am talking about the black hole itself is having the mass of anywhere between 29 to 36 times. Then imagine the mass of that star which has given the black hole. Got the point? Whenever the massive star explodes, what is the product? Black hole is the product. What is the mass of these black holes? Anywhere between 29 to 36 times as that of the mass of sun. This is what the calculation they made. When the black hole itself is having such a great mass, which is quite larger than the mass of the sun, what about those stars which have left the black hole with such a massive mass? Such a huge black holes around some 1.5 billion years. Around some 1.5 billion years, what happened? They have fused. Not today, in the recent past. They fused some 1.5 billion years back. The moment once they fuse, the gravitational waves are spreading just like the ripples in the water. What is a ripple? Whenever you are throwing a pebble in the standstill water, you can find the ripples. The series of waves, not just one wave, a series of waves will be coming on the same lines. You can find the ripple effect that is created because of merging of two black holes. Thereby, the waves called as the gravitational waves took birth and they are spreading throughout the space. This was discovered with the instrument called as LIGO. What do you mean by LIGO? It's nothing but light interferometry gravitational wave observatory. This is called as LIGO. This is the instrument with which we are discovering the gravitational waves. The gravitational waves are so weak. They are so weak and they have taken almost all 1300 million years to travel from that point of origin towards Earth. Right now, they are passing by the side of the Earth. When they are passing by the side of our solar system, now we discovered how much distance they have traveled. They travel almost some 1300 millions of years. Even today they are moving. In order to study this one, right now there are three such centers. One is called as LIGO, another one is called as WIGRO, and the last one is called as KAGRA. These are the three very important centers that are present to observe the gravitational waves. The fourth one, they are planning to establish in the year 2022 in the month of December. Meaning what? Whenever that fourth one is going to establish, that will be there in the newspaper, you need to check that one. When they are planning to establish the fourth lab, it is in the month of December 2022, this year. Is it clear? What is the structure of this LIGO? It is something like this. Suppose, if this is the main center, it is having two subsidiary offices where the connectivity will be there like this. This is what the mirror. From here the source is being sent. From here the source is sent. The gravitational waves are sent. The mirrors will reflect back the wave. Whenever the wave is coming back, then what happens? They will be studying the properties of the gravitational waves. This is what the mechanism. What is the distance between the arms of this LIGO? It is 4 kilometers. It is 4 kilometers. When the wave is passing right from the 4 kilometers of distance, right from here we will be observing how it is moving, what are the properties of the gravitational waves, and how they should be detected. If they are moving in with the frequency more or less, what is the meaning? All it is studied right now. There is a biggest challenge for this for the physicist. What the challenge was? This distance, the distance of 4 kilometers is very, very short distance for them to apprehend the properties of the gravitational wave. They gave a call to the world communities, world scientists. We need to establish such a big lab, such a big antenna, so that the distance of this one can be some millions of kilometers. It is just 4 kilometers. Within the 4 kilometers, whatever the behavior of the wave is there, we can study. But is it a perfect behavior of the wave? When the wave can be behaving perfectly whenever the distance is more. And so they gave a call to all the astrophysics of the world. And by the time they gave a call in the year 2019, what happened? In the year 2019, ESA, European Space Agency came forward with a consortium. What is a consortium? All the world scientific community who are interested to work in this project, they came forward and they have decided, yes, the European Union is going to finance this particular project, and they named this project as LISA. What is this project? LISA is nothing but Light Interferometry Space Antenna. This is going to establish, this lab is going to get established somewhere in the year 2030s. Right now the project work is going on. Within 2030s, maybe 2030 or 2031 or 2032 or somewhere till within 39, they are going to place this antenna in the space. What is the importance of this LISA? This is LIGO, right? The same structure is there. Now, the arm of this LISA is around some 2.5 million kilometers. It is 2.5 million kilometers. At 2.5 million kilometers, the subsidiary offices were established. The main center is at the tri-junction, is a triangular shaped. This is what the LISA that is going to establish somewhere in the year 2030s. And the funding is given by the European Union. Some of the Indian astrophysicists are also participating in this experiment. They gave their consent. Yes, we are going to participate in this one. Because these experiments cannot be conducted by one scientist or two scientists. They need a group of scientific community. Therefore, they are inviting all the young scholars. All the young scholars are working on this one right now, and probably by the time it is 2030s, they'll be launching this particular space antenna in the space. It will be placed at a place called as L1. There are certain points specifically located around the earth. What are these points? Suppose if this is a globe. It is a globe. This may be sun. Around the globe, there are certain points like L1, L2, L3, L4. What are these L1? L means what? Lagrange. The Lagrange point or Lagrangian. This is also called as Lagrangian point or Lagrange point. What are these points? These are the points where the gravitational pull of the sun and the centripetal repulsion force of the earth are very, very minimum there. Since the force of attraction and the force of repulsion is very minimum, any object, if it is placed here, it will be utilizing very minimum energy for its stay, and it will be keep on rotating like this. These are the points called as L1, L2, L3, L4 points. These are the points. The scientific community has discovered these Lagrange points, and Lisa is going to be placed in the L1 position. What is L1 and L2 and all these things you will be coming across in the science and technology. This is about the current scenario. This is the current scenario where the space and the developments are happening. But the question remains. What is the question? Sir, when the Big Bang theory is a hypothetical in nature, why the atom is exploding, we don't have the perfect reason, then why we need to accept this as a valid theory? The normal question that should be raised in the mind, no, what is the question? Why we need to accept this particular theory? Is there any scientific supporting material is there? Are scientific evidences are there? Yes, the scientific evidence is there. That's why we are accepting this theory as a valid theory right now. Like, he gave the theory in the year 1927. Who is the guy? Georges Lemaitre. Who is the guy? The Georges Lemaitre. He is nothing but the Belgian priest. This guy was supported by the very great scientist by name Mr. Edwin Hubble. The very next 2 years, within the 2 years after the Georges Lemaitre proposed this concept, it was supported by Mr. Edwin Hubble. How is Edwin Hubble supported? In fact, he doesn't want to support, but accidentally it happened. He was having the telescope and he was seeing the space. When he is staring at the space, what he could discover is there is a red shift. The very, very important concept. Because of this red shift, who became very popular? Edwin Hubble became very popular. What do you mean by red shift? What, according to Mr. Hubble, when he is observing the celestial bodies, all the objects, whatever the objects that are available in the space, he is looking through the telescope. When he is seeing all these objects, each and every object is moving away from each other. You talk about any two objects, when they are calculating the positions of the object on one day and the other day, then the distance is increasing. When all these objects are moving away, meaning what? The space is ever expanding. How he has proved this one? With the concept called as red shift. What, according to the Hubble, is a red shift? Now, understand like this. Let me put like in a very common way where you can understand easily. Suppose if at all you are staying on the road. If an ambulance is approaching you, what is the ambulance? It will be making so great sound, right? Whenever it is approaching you, what happens to the intensity, frequency of the sound when it is coming close to you? It will keep on increasing. The moment once it moves away, the frequency receding. It starts receding, right? This is what called as the Doppler's effect, right? In the physics, there is a concept called as Doppler's effect. Forget about the Doppler's effect and all these things. Think very practically. You might be not knowing the Doppler or some other persons, but you are there on the road when the ambulance is coming. When the ambulance is coming, then you will be hearing the sound of this ambulance with a greater intensity when it is coming towards you. The moment once it moves away, what happens to the intensity of the sound? It will be keep on subsiding. On the same lines, whenever you are seeing the light that is present in our solar system, like, what is the spectrum? This all you people know. What is this VIBGYOR? Or nothing but the frequency of the light. Violet, indigo, then blue, green, yellow, orange and red. Why this is named as the acronym VIBGYOR? According to the frequency levels. The left hand side waves, side colors are having high frequency, and the right hand side are having low frequency. Meaning what? Whenever you are moving from right to left, the frequency will be keep on reducing. Got the point? Who is there in the right? It is B. Who is there on the left? The brightest colors. There are three bright colors. One is blue, another one is green, another one is red. Green is there in the middle, blue is that extreme, the right hand extreme, and the red is in the left hand extreme. The moment once any object, any celestial body is coming towards our solar system, it will be exhibiting high frequency, nothing but it will be exhibiting blue light. It will be exhibiting blue light. Any celestial body which is approaching towards our solar system, towards our earth, what happens? It will be exhibiting blue light, meaning what? The frequencies keep on increasing. Whenever the ambulance is coming, what happens to the frequency? It will be keep on increasing. On the same lines, any celestial body, whenever it is approaching to our solar system, it will be exhibiting the blue light. The moment once it passes, it exhibits what is called as the red shift. What is the red shift? Nothing but low frequency. The frequency will be keep on reducing. This is what called as the red shift. All the celestial bodies with respect to each other, they are exhibiting red shift, meaning what? They are moving away from each other. When they are moving away from each other, what is happening there? The universe is expanding, as given by Mr. Georges Lemaitre. Why it is expanding? It is exploded. This is what he said. But Hubble didn't say that it got exploded. What I know, what I can prove very practically, very scientifically is, yes, the space is expanding because of the red shift. All the celestial bodies are exhibiting the red shift, meaning what? The red frequency is there, meaning the reducing frequency. When they are reducing frequency will be there whenever they are moving away. Whenever they are coming closer, definitely it will be the blue frequency will be there. Therefore, with this concept, he supported Lemaitre. Also, another very important evidence is there. In the year 1962, the two very important astrophysics, one by name Mr. Penzias. One guy is called as Penzias, another one is called as Wilson. These are the two, again, very important physicists where they discovered very great radiation in the entire space. In the entire space, what they discovered is radiation. According to them, the radiation can be there whenever there is an explosion. When there is an explosion, then only radiation should be there. Because of the explosion that has taken place around 13.7 billion years back, might be this explosion is the reason for this radiation. Who gave this time period? It is Mr. Belgium priest, Mr. Georges Lemaitre. Around 13.7 billion years, one single atom, it got exploded. As it is very single atom which got exploded, this concept was called as singularity. This is called as the singularity, meaning what? One single atom got exploded and created so much of space. This is the concept called as singularity concept. Who gave this one? Georges Lemaitre. What was discovered in the year 1962? Radiation in the entire space. Wherever you see in the space, you can find the radiation. When the radiation can be there, provided there is an explosion. Probably this is the explosion. That is what the people are connecting. In order to prove all these things, in the year 2008, see, we are coming to the latest time period. We are not talking about the 1760s. In the year 2008, there was a very great lab. In that lab, the name of the lab is called as the CERN lab. CERN. In the CERN lab, where it is located? You know, there are many scientific products from the CERN lab. Your Apple phone creator, the so-called Steve Jobs, is also a product of this lab. Majority of the modern scientists are from the CERN lab. Where this lab? This lab is located not on the surface. It is almost all 1 kilometer of depth in the inner layers of the earth for about 25 kilometers of width in between Switzerland and France. In between France and Switzerland, at around along the boundary, the common boundary between the France and Switzerland, at a 1 kilometer of depth for a stretch of 25 kilometers of width, there was a lab that was constructed. The name of this lab is called as the CERN lab. In this CERN lab, there was a very great experiment conducted called as LHC experiment. What is this LHC experiment? It's called as Large Hadron Collider. The Large Hadron Collider experiment. What is this Large Hadron Collider experiment? In fact, it is a tube-like structure. In the lab, there was a tube-like structure is there. They developed a tube-like structure. Within this tube-like structure, they have separated two protons from the atom. What is the atom? Round ball, in which at the center, what is there? Nucleus. Within the nucleus, you can find the positively charged particles. What are these called as? Protons, right? The scientific community has separated two protons, and what they believed, when two protons are made to rotate at a speed of light, made to move at a speed of light, and when they are bombarded in opposite direction, what can be created? Matter can be created. This is what the matter can be developed whenever there is a collision between the fast moving protons. This is what they believed. What they believed is, whenever the two protons which are moving at a speed of the light, meaning what? 3 lakh kilometers per second, when they are brought in opposite direction, they are made to collide. When they are made to collide, definitely you can find the formation of the dust and some of the gas particles. That is what called as matter. These are the basic ingredients for the development of the universe, right? What happened in the case of the Big Bang theory? Explosion. Because of the explosion, what developed? Gas and dust particle, nothing but matter developed. Is it clear? The same way, here also we are going to see matter. This is what the belief of the scientists, and they conducted the experiment in the year 2008. What happened then? They made the two protons to move in opposite direction, circulated, and the speed of light, they were brought to the speed of light, and finally they made the two protons to come in opposite direction and collided. The moment once they collided, what was the result? There was no matter created. When there was no matter created, now the people conducted the experiment again in the year 2012. They conducted the experiment in the year 2012 again, meaning what? Again recently. Again they have taken two protons, again they have circulated, made the proton to move at a speed of light, and again they bombarded. The same result. When the result was there, but they could understand one thing. Definitely the result should be positive, matter should be created, but what the mistake we did is, we selected protons from a common atom. What is that atom which is not having the infinite mass and infinite energy? We need to have such an atom where the atom should be of infinite mass and infinite energy. What that atom is called as, what that atom was named as God particle. Meaning what? There are certain atoms with a very high energy, very high mass, infinite energy. These are called as the God particles. When we separate the protons from the God particle, definitely matter is going to create. This is what the conclusion they came to. When all the human works didn't give a desired result, what came into picture? God came into picture. What is this God particle? In fact, the God particle was named as God particle by two very important scientists. One is called as, the God particle is called as Higgs boson particle. What is the common name? The common name is the God particle. What is the scientific name? Higgs boson particle. What do you mean by the Higgs boson particle? These are the two, again, very great physicists. One is Higgs, who happens from the European scientist. The another guy, Mr. Bose. Our Indian scientist by name Mr. Satyendranath Bose, popularly called as S.N. Bose. These are the two personalities who have discovered that yes, there are certain particles where they are called as Higgs boson particle. These particles are having infinite mass and infinite energy. But now the scientific community, entire scientific community, are searching for the God particles. Once the God particle is discovered, then what happens? The experiment again will be resumed. When the experiment is resumed, probably they may be creating the new universe. We don't know. When this experiment was happening in the year 2008, in India, the entire media was creating so much of what is called as a rumor. Is it a doomsday today? Media is like that. What media has given? They need some news, and therefore they have published that. Is it the doomsday today or what? Because they are conducting the experiment. If it gets exploded, a black hole is created. What happens? The black hole will be absorbing all the material, and the black hole is not there on the space, but is there here on the surface of the earth. All we people are going into the black hole. Probably this is the doomsday. This is what the people created so much of fun. And finally, the result was nothing. Right? This is about the entire scientific advancement regarding the universe. Let us talk about, after the scientific advancement and whatever the discoveries that are made, all these things, let us talk about the structure of our solar system. Before going to the structure of our solar system, let you take down some few points as your reference. Let you take few points as the reference, and again mind you, I won't expect questions from this part. It is all for your understanding, just to know where are we in the universe. Though I have given some of the latest developments like the LIGO, like LISA, probably you will be coming again in the science and technology. Someone will be taking care of this one. But I don't think so they will be the questions in the prelims. Why? Because these things were developed in the year 2019 itself. When they were gravitational waves were discovered in the year 2015, by the time it is 2019, all the people came out with all the developments. So they were no more current. But as a aspirant, you should be having the knowledge of this one. Come on, write down. Take down the few lines regarding the universe and the birth of the star and all these things. Yes, come on, go ahead. Yes. Huh? Yes. Now see the question. What is the question is, whenever you are talking about the high frequency and the low frequency, you have taken the red as a low frequency. That we can understand because that is the lowest of the waves here. But whenever you are talking about the high frequency, beyond the blue also, there is another color like indigo is there, violet is there. Why didn't you consider as the violet or the indigo shift? Whenever you are talking about the approaching material, it is exhibiting the blue color. Why it is not the violet color? Because in the entire universe, whenever you are talking about the colors, there are three bright colors. So bright colors, they are dominating all other colors. Though the frequency of the violet and the indigo is much more than that of the blue, it appears bluish only. It appears bluish only, and so it's called as the blue shift. What are the dominant three colors? With the combination of different colors only, from these three colors only, all other colors comes into picture. Right? Blue, green and red. And might be many times you might have come across the word called as infrared. Right? All you people are well aware of the waves called as, or the light called as infrared rays. What do you mean by infrared? Now see this one. Where is this here? What do you mean by the infrared? Those waves which are having the frequency less than red, they are called as infrared. There is no such unique wave or something. What are those waves which are called as infrared? Nothing but lower than red. Got the point? the wavelength or the frequency of these waves is less than the frequency of the red wave, which are called as infrared waves. Is it clear? If the wavelength is more than this one, supra, more than blue wavelength, right? This is what the meaning is called as infrared. Many times you'll come across this infrared. What do you mean by infra? Below red. Below the red wave frequency. Is that clear? Is it okay? That is what the color. The color is blue in color, not the violet or indigo. Right? Come on, give the ideas. Big Bang. Propounded by Mr. Georges Lemaitre in the year 1927. Big Bang theory propounded by, whatever I explained, I am dictating right now. Okay. Propounded by Georges Lemaitre in the year 1927. Under this one, right now, according to him, the universe was extremely compact. The universe was extremely compact, C-O-M-P-A-C-T, compact, dense, small, and singularity. Compact, dense, small, and singularity, there was no other matter. There was no other matter, no space, existed, E-X-I-S-T-E-D, existed, and no time too. This is what you will be telling every time. Sir, where is the time, sir? No time to, T-O-O. Okay, don't write T-W-O. Okay. No time to, full stop. Around 13.7 billion years. Around 13.7, 13.7. Around 13.7 billion years ago, a cosmic explosion happened. A cosmic explosion happened. Cosmic, C-O-S-M-I-C, cosmic explosion. Explosion happened, called Big Bang. Called Big Bang. With that, the universe started. With that, the universe started and expanded. And expanded, continuing, even today. Continuing even today. The explosion subsequently, give a full stop and write down the next point as the explosion subsequently created the forces like gravitational pull and the elementary particles like atoms, molecules, gas clouds, dust particles, stars, and a cluster of stars, called galaxies. Cluster of stars called galaxies, 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 etc. Next para. After etc., give a full stop, write down the next para. In 1929, Edwin Hubble. In 1929, Edwin Hubble proposed all the observable stars and the galaxies, Galaxies, all the observable stars and the galaxies are moving away from each other. Which he discovered from red shift, within the inverted commas. Red shift. Write down within the inverted commas. Red shift. REDSHIFT. Full stop. The rate of expansion he called as Hubble constant. Hubble constant, Hubble, Hubble constant. Meaning what? At which rate the expansion of the galaxies and the stars is happening? It's called as Hubble constant. That he himself named after his name. Just like our Chandrasekhar has named after his name, called as Chandrasekhar limit, he is naming after his name called as Hubble's constant. Give the next heading as the life of the star. Life cycle of a star. Life of a star. All stars form in nebula. All stars form in nebula. All stars form in nebula, which was a huge cloud of gas and dust, though they shine for many thousands, they shine for many thousands and even millions of years, though they shine for many thousands and even millions of years, stars do not last, last forever. They do not last forever. Full stop. The changes that occur in a star, over time and its lifespan depends on the star size. Next para. Nuclear reactions at the center of the star. Write down in the next para. The nuclear reactions at the center of a star, provides energy which makes it shine brighter. Which makes it shine brighter. This stage is called main sequence. MAIN, main sequence. Simply the term. Okay. What is the first stage of the star? Is called as main sequence. It's called as the main sequence. Full stop. The lifetime of the star depends on the lifetime of a star depends on its size, comma, on its size, comma. Massive stars, massive, M-A-S-S-I-V-E, massive stars use up their fuel quickly. Massive stars use up, U-S-E, use up their fuel, the fuel, F-U-E-L. The massive stars use up their fuel, F-U-E-L, quickly. This means they live only for a few. This means they live only for a few hundreds or thousand years. While the smaller stars use up their fuel, F-U-E-L, use up their fuel more slowly, use up their fuel more slowly, so they will shine for several billion years. Several billion years. Several billion years. Write down in the next para. The star has two ways. The star has two ways. The star has two ways to end up its life. To end up its life, depending upon the mass of the star. Depending upon the mass of the star. Full stop. This was discovered by Mr. Chandrasekhar. This was discovered by Mr. Chandrasekhar through his concept within the inverted commas, the Chandrasekhar limit. Through his concept, the Chandrasekhar limit. The Chandrasekhar limit. According to this, if the mass of the star is less than 1.44 times the mass of sun, if the mass of the star is less than 1.44 times the mass of the sun, less than 1.44 times the mass of the it turns into white dwarf. It turns into white dwarf. It turns into white dwarf. Simply, this is what the entire equation, right? Full stop. If the mass of the star is more than 1.44 times the mass of our sun, if the mass of the star is more than 1.44 times the mass of the sun, it turns into supernova. It turns into supernova. Full stop. Another this one. A white dwarf is a white dwarf, D-W-A-R-F. A white dwarf is a bright, hot, dense core. A white dwarf is a bright, hot and dense core. Full stop. About 6% of all known stars, in our Milky Way, are the white dwarfs. White dwarfs. Full stop. These will eventually turn into black dwarfs, black dwarfs after millions of years. These will eventually turn into black dwarfs after millions of years. Full stop. Write down the next para. A massive star experiences more violent end. A massive star experiences more violent, V-I-O-L-E-N-T, violent end. Full stop. It explodes as supernova. It explodes as a supernova. It explodes as a supernova. Full stop. The scattered material from inside the star collects in the nebula, C-O-L-L-E-C-T-S, collects in the nebula and forms the next generation stars. And forms the next generation stars. And forms the next generation stars. Full stop. Full stop. After this one, write down. When the cloud of stardust, S-T-A-R-D-U-S-T, stardust clears, then the dense material that was left behind after the collapse of the star, is called a neutron star. These spin rapidly and can give off OFF of streams of radiation known as pulsars. P-U-L-S-A-R-S, pulsars. Full stop. If the star is extremely massive. Full stop. After this one, continue the line. If the star is extremely massive, it explodes to form a black hole. It explodes to form a black hole. Full stop. A black hole is a dense and incredibly dense and incredibly having greater gravitational force in them. Greater gravitational force in them that nothing can escape its pull. Nothing can escapes its pull. Full stop. Next para. In 2015, the scientists announced that they had the first evidence of the gravitational waves. That they had the first evidence of gravitational waves. Full stop. The waves came from the merging of merging of the two massive black holes. Which were about 29 to 36 times the mass of the sun. 29 to 36 times the mass of the sun. Full stop. This event took place over 1.3 billion years ago. Full stop. The scientists use laser interferometers. Laser interferometers like LIGO. Use laser interferometers like LIGO, hyphen and expand the abbreviation. Light interferometry gravitational wave observatory. What is LIGO? LIGO is nothing but light interferometry gravitational wave observatory. Spelling is there on the board. Light interferometry gravitational wave observatory. To detect the gravitational waves in the space. Full stop. As on today, LIGO, Virgo and Kagra, again spellings are there on the board. As on today, LIGO, Virgo, not Vigro, it's Virgo and Kagra have written as Vigro. No, wrong. Okay, Virgo, Virgo. As on today, LIGO, Virgo and Kagra are the observing run plants, run plants, and the fourth observatory center is planned to establish in December 2022. Full stop. The European Space Agency, ESA, the European Space Agency plan to launch the European Space Agency plan to launch LISA in 2030s. LISA in 2030s. Write down LISA. What is LISA? Sorry, it's not light, it's laser. Laser interferometry space antenna. LISA, laser interferometry space antenna. Laser interferometry space antenna will be the first telescope, in the space, to study the gravitational waves. Full stop. The three spacecrafts of the LISA, crafts of LISA will be 2.5 million kilometers apart, in a triangular shape, such a long arm, long arm, arm of LISA makes more sensitive to study the gravitational waves, in the space than LIGO on the land surface, which has arms, arms only 4 kilometers long. Right? Could understand this statement? What is the difference between the LISA and the LIGO? LISA is having the arm of 2.5 million kilometer, whereas LIGO and all other Virgo and what is the other one, Kagra, they are having the arms of just 4 kilometers. Why? Because they are there on the land. One in USA, another one in some other places, right? They are present on the land. Whenever it is on the land, the size should be limited, but it is in the space where we can establish whatever the size we want, because space is more. Got the point? This is the condition, right? With this, whatever is explained to certain extent is been dictated. Now let us see the general understanding of the solar system. How many planets are there? Why they are located there and how they are there? What are the compositions? All these things we will be discussing after a small break. Okay, let us go for a break. After the break, we will be taking up the other concepts like solar system and all these things. Yeah. Those who didn't collect the magazine yesterday, you can collect it today. Okay. When the institution is providing the current affairs magazine, why are you not taking that one? You can take that one, you can read once, right? And yesterday also everyone is asking like, sir, you are giving the references like NCERT and you said about the class notes, but why didn't you mention that the vision material should be read? That is by default. Whenever it is given by the institution, that needs to be read. There is no specific statement given by me to read that one separately. When that is provided by the institution, definitely you need to go through once, right? Everyone is asking. Sir, you didn't specifically mention, Dane mein kuch kala hai, what is that one? Shall I read that one or not? You are having some skeptic idea about the institution material. Arey Baba, I don't have any such, even I don't have such great knowledge. Okay, to be skeptic about the institution material. Simply, I didn't refer. Why? Because I believe that whenever it is given to you, you will be definitely following that one. Okay, in that there is no great logic. Don't see inside with the magnifying lines. Okay, there is no such logic there. You can read once that one. Fine. Then, after this one, give rating as a solar system. Come on. What do you mean by the solar system? And in fact, whatever the discussions that have taken place just now regarding the star and all these things, all they are related to the physics and astrophysics. There are many physics principles are there. Like, there is a law of friction, the law of conservation of energy, the law of angular momentum. Since many of the people are from non-science background, I am not going into all these things. Instead of explaining with the physical experiments and the physical names, I am just giving as a common, in a common way, so that each and everyone can understand. Okay. These are all the things that are there. All they are related to physics and astrophysics. That is not our geography. Right? We are yet to enter into our geography. Right? Then, after this one, give rating as the solar system. Come on. What is the structure of solar system? What are the particles that are there? What are the different names given to these celestial bodies? Let us see all these things. Give rating as solar system. What is the solar system? Very good. What is a system for that matter? What is a system? We will be using this word very freely, very easily. But the very word system has got greater meaning. The very word system has got greater meaning. Like sometimes your laptops, whatever the lapis you are having, you will be calling that as system. Where is my system? Where is my system? This is what you will be questioning your mom. What is that one? Lappy. Lappy itself is called a system. The computer itself is called a system. Right? What is the literal meaning of the system? Very good. In which different components are organized. In which way? In a systematic manner. That's why it is called a system. When the components are organized in a systematic manner, it's called as a system. Now, understand this one. Whenever you are talking about our body, you are having the system again, the digestive system, the reproductive system, respiratory system. That is also called a system. What is the general meaning of the system? Meaning what? If any one framework, if it needs to be called as systems, it should be having two very important things. One is called as input. The input needs to be processed to turn into what is called as output. Whenever there is an input, based on the type of input, you can find the output, and there is a feedback mechanism. This is what called as a system. Here also, the system that is present is called as the solar system. What is that solar system? Input. What is the input? Someone is giving the input for us. What is that input? Nothing but the sunlight which is emitted by the sun. Because of the sunlight only, all these things are happening on the surface of the earth. All these things is what? The existence of the life itself is there on the surface of the earth. What is that energy that is possessed by the earth? The entire energy for the earth is by or from the sun. The sun is the ultimate source of energy for us. In all our bodies, what is that thing that is present called as energy? From where that energy came from? The sun. That sun's energy got manifested in you. Is it no, sir? Is it? How can we say that one, sir? The sun's energy is present in me or what? How it is present? See, all you are having energy, you can lift your hand, you can write, you can listen, you can see. All they are because of the energy. From where you got the energy from? Because, sir, the class is at 1 o'clock, at 12 o'clock. Have taken something. What is that something? It is the energy, which is called as the chemical energy. Who has produced that chemical energy? The autotrophs. Autotrophs has converted the photo energy into chemical energy. What is the photo energy? The sunlight. The sunlight, which is the energy, since the energy cannot be destroyed nor created, can be converted. The photo energy got converted into chemical energy and the plant is storing in its own body. When the plant is storing in its own body in the form of the bulbs, like this is what the bulb, what the man is doing. The plant, whenever it wants to store the energy for its own consumption in the future, man, what he is doing? He is cutting all these bulbs and he is taking. What is there present here? The photo energy got converted into chemical energy and now the man is taking that chemical energy into him. And that energy is manifested in the form of all writing, listening, seeing, walking, running, all these things. That is what the energy. The entire energy on the planet Earth is because of the sun. That is what the input. The energy that is consumed is also again given out into the space. That is what the output. Therefore, a very great incoming and the outgoing is perfectly balanced, which is called as the input and the output is there. Therefore, this is called as a system. The solar system. Simply it is defined as the sun and its family. What is the solar system called as? The solar system is the sun and its family. Its family is called as solar system. Come on, write on this one. What is the solar system? The sun and its family is called as the solar system. Meaning what? Sun is having a family. Let me show the family of the sun. All you people are wondering like, oh, sun is a family man. Till now I thought like sun is a celestial body. Is he a family man? Yes, he is a family man. Got the point? He's having a big family. What are the family? Who are the family members? Come on, see the family members. The first and foremost, personality. Nothing but the celestial body. The planets. What are the planets? 1, 2, 3, 4. Then you can find so many dust particles. So many dust particles are there. Then after this one you can find the larger one. The larger planets. The larger planets like this is what the family of the sun. The sun is having 8 family members. These are called as the planets. These are called as the planets. The planets are of 2 types. One is called as inner planet, another one is called as outer planet. There are 4 inner planets, there are 4 outer planets. These inner planets, they are also called as terrestrial. Very good. They are also called as the terrestrial planets. They are also called as the terrestrial planets. Whereas the outer planets, they are called as Jovian planets. Okay? They are also called as the Jovian. Jovian planets, nothing but they are Jupiter type. What is the meaning of Jovian? Nothing but Jupiter type. It is similar to that of the Jupiter. Therefore, they are called as the Jupiter type planets, Jovian planets. Also, these 2 are called as the gas giants, whereas these 2 are called as the ice giants. What are the names? The first and foremost one is called as Mercury. It's called as Venus. This is Earth. This is Mars. This is then. Very good. And Neptune. These are the 8 planets as on today. But earlier, meaning what? Before 2006, there was another planet called as the Pluto. Let us first of all discuss about these 4, then we'll talk about the Pluto. Come to the terrestrial planets. What are these terrestrial planets? Why they are called as terrestrial? These planets are having greater density. Right on the first point. The 4 inner planets. Meaning what? These planets are very close to the Sun. Which planets are closely located to the Sun? The terrestrial planets. They are having higher density. Meaning what? Mass by volume. What do you mean by density? Density is nothing but mass by volume. Whenever you are talking about more density, simply imagine like, weight. Whenever you are talking about the density, which planets are having high density? Whether it is the Jovian planets or the terrestrial planets, all the terrestrial planets are having more density because they are made up of rocks. Come on. They are having high density. Point number 1. Siding terrestrial planets. After drawing this picture, after drawing the entire picture, give the side heading as inner planets or terrestrial planets. Inner planets or terrestrial planets. Recall as inner or the terrestrial planets. Then the first point, they are having high density. They are having high density. Why they are having high density? Because they are made up of rocky material. Come on. They are made of rocky material. They are made of rocky material. Then they are made of a rocky material. They have thin atmosphere. Next point. They are having thin atmosphere. Meaning what? What do you mean by atmosphere? What is atmosphere? The gases around the planet is called as atmosphere. They are having very thin atmosphere. Unlike the Jovian planets where they are having very thicker atmosphere, the terrestrial planets are having thin atmosphere. Then the center of these planets is having a liquid core. The center of the terrestrial planets is having a liquid core. Instead of liquid core, write down as iron core. The center of terrestrial planets is having the iron core. Iron core. The last point, they are having slow rotation. They are having slow rotation. Why they are having slow rotation? Since they are denser. Whenever it is denser, it has to be slow in rotation. Now the general question. Don't write anything. Just see the one. Out of the 4 inner planets, what are the 4 inner planets? Mercury, Venus, Earth, Mars. Which is the smallest one? All you people are very 100% sure that Mercury is the smallest one. Now the question, which is the largest one? Out of these 4, A, Mercury, B, Venus, C, Earth, D, Mars. If this is the question, a simple question asked by UPSC, maybe in the prelims. Out of all the 4 inner planets, which is the larger planet? Mars. Which is the largest planet? See, that is the problem with the Indians basically, not the Europeans. Europeans are having so great self-centered attitude. We people, Indians, we feel ourselves very low. We people feel ourselves as we are inferior. In fact, see this one. We always think that Mars is larger one, Venus is larger one, without having the self-respect in us. What is this one? Earth is the larger one. Got the point? Which is the biggest planet of all the 4? It is the Earth. Earth is the larger planet out of all the 4 inner planets. Next rank goes to The Earth's twin, Venus. Second rank goes to this one. And the initial answer what you have given is Mars. Mars is just the third ranking. The third ranking planet. Is it clear? Which is having the larger size? It is the Earth. Earth is larger in size. Clear? Now, out of these four inner planets, which planet is having high density? All they are denser planets, right? All they are the denser planets when compared to the gaseous planets. Out of all these four planets, which is the denser planet? Sir, Earth, sir. Mercury, sir. Why? Because, confidence is high. As and when the word gets end, the confidence becomes low. Mercury, sir. Which is the denser planet? Again. Self. Got the point? Earth is the denser planet. If there is a question like, out of all the planets in the solar system, which is the densest planet? ABCD again. Sir, you please give me ABCD, then only I can answer. One is Mercury, Saturn, Jupiter, then finally you can give Earth. Which is the densest of all the 8 planets? It is again. Earth is the densest planet of all the 8 planets. Got the point? Because of its greater density only, where the planet is very stable. Unlike other planets, the other planets are also stable, but out of all the 4 planets, our Earth is very constant and very stable. This is the one. A very great planet. The planet where you can find the life is the Earth. This is the one. Out of all the planets, which is the densest planet? It is number 1, Earth. Come on, write on. Out of all the planets, the densest planet is Earth. Out of the inner planets, which is the largest planet? It is again the Earth. Then the second, which is the second densest planet? Out of all the planets of the solar system, which is the second densest planet after the Earth? ABCD, sir. This is ABCD. Which is the second densest planet? Mercury is having almost all equivalent density to that of the Earth. If at all I am giving the number, come on, let us see the number. The density of the Earth is 5.52 grams per cubic centimeters. What is the unit of density? Grams per cubic centimeters. The density of the Earth is 5.52 grams per cubic centimeters. What is the density of Mercury, which is the second densest planet? It is Mercury. Mercury is having the second great density of 5.50 grams per cubic centimeter. Meaning what? Almost all equal in density. Earth and Mercury are almost all equal in density. But Earth is somewhat more in density. Right? This is about the inner planets. They are rocky structured and they are having high density. And the core is made up of the iron. Iron core is located in all the 4. In all the 4, the core is iron. Iron is dominantly present there. Then comes to the second one. The outer planets. Siding outer planets. Outer planets are the gaseous planets. The gaseous planets. Their temperatures are cool to cold. The temperatures are cool to cold, whereas the inner planets' temperatures are warm. Why they should be warm? The inner planets are having warm temperatures. Why? Because close to sun. Whenever the planets are far away from the sun, definitely their temperature should be cool to cold, right? Then their light intensity, their light intensity, they are larger in size with thick atmosphere. They are larger in size with thick atmosphere, and they rotate very fast. And they rotate very fast. Out of the 4 outer planets, continue the point. Out of the 4 outer planets, Saturn is the least density planet. Saturn is the very least dense planet, whose density is very, very low, less than 1. The density of the Saturn is less than 1, 0 point somewhere around 52. The density of the Saturn is very least, meaning what? When we are comparing the density of the Saturn, we said that it is less than 1, meaning what? It is the planet which is less than the density of the water. Meaning what? If by mistake, if Saturn is falling on the water, it will be floating on the water. That is what the density. The density is very, very low for Saturn. Out of all the 8 planets, which planet is the least densiest planet? It is the Saturn. Which is the high density planet? It is the Earth. The second rank goes to Mercury. Now, in 2006, come on, this is very important one. In 2006, International Astronomical Union, IAU. In 2006, IAU, International Astronomical Union, International Astronomical Union has redefined the definition of planet. Redefined the definition of planet. With this new definition, has redefined the definition of planet. With the new definition, Pluto was placed under dwarf planet. It was placed under dwarf planet. Meaning what? Till 2006, Pluto was considered as a planet, but right now it is considered as dwarf planet. Right? This is what the one. But what is the definition of the IAU for the planet? What are the definitions? Let us see the definitions. Don't write anything. Let me explain, then you can write. IAU has given 3 conditions for any celestial body to be called as a planet. What are the 3 conditions? The first and foremost condition is any celestial body that is revolving round the sun should be called as the planet. Meaning what? It should revolve. If it is a planet, it should revolve round the sun. It should revolve round the sun. If any object is revolving round the sun, it should be called as planet. Is this condition is satisfied with the Pluto? Yes, Pluto is revolving round the sun, therefore it should be called as a planet. Not only the Pluto, all the asteroids that are present, all the dust particles that are present, all the comets that are there, every material is revolving around the sun. Therefore, all they should be called as planets according to this definition. But second condition, what is the second condition? It should have enough mass. Any planet, if at all, any body, if at all it wants to be called as a planet, it should have enough mass. It should have enough mass so as to maintain hydrostatic equilibrium. Hydrostatic equilibrium. So as to maintain hydrostatic equilibrium. What is the meaning of this statement? See the second very important criteria given by the IAU. For any object should be called as a planet, it should be having enough mass. Not only it should be having enough mass, with this mass it should maintain hydrostatic equilibrium. Meaning what? Simply it should be having mass, and because of its equilibrium it should be a round ball like structure. Simply meaning what? It should be round ball like structure. It should be round in structure. That is the meaning. What is the meaning of this one? In order to maintain the hydrostatic equilibrium, that body should be round ball like structure. If at all you are seeing the size of the Pluto, shape of the Pluto, it is round ball like structure. Therefore, this criteria is also been satisfied by the planet Pluto. With this criteria, majority of the asteroids which are irregular in shape are delisted from the category of planet. Then the last criteria. With this criteria, Pluto was kept aside. Under the category of dwarf planet, it was included. What is this criteria? Its criteria, the last one, it should have cleared its neighborhood. It should have cleared its neighborhood. Meaning what? Any celestial body, if it is revolving around the sun, if it is the sun, any object which is revolving around the sun, which should be having a revolution, it should be having round ball-like structure, and it should have cleared its path. What do you mean by clearing the path? In this path of this planet, it should be the larger one. There should not be another larger objects within this path. Got the point? Whenever any object is revolving around the sun, which is round ball-like structure, and in its path, it should have cleared the path. What do you mean by clear the path? In its path, there should not be no other larger object except this one. But in the case of Pluto, in the same path, very close in the neighboring hood, there are two dwarf planets were discovered. When two other planets were discovered in the year 2005 and again in the year 2004, now the question of giving those objects the category of planet or removing of the planet category for the Pluto arised. Got the point? There was a dilemma for the scientific community. When the two objects within the same orbit was discovered along with the Pluto, then there can be two chances. What are the two choices for the scientists? They should consider those two objects as new planets, making the planets as number 11, from 9 to increasing the number of planets to 11, or delist the planet called as Pluto also, where all these three were considered as dwarf. Meaning what? They have chosen the second choice. Instead of increasing the number of planets, they have removed the planet called as Pluto from the category, and then it was placed under the dwarf category. This is what the condition. What do you mean by the clearing the neighborhood? In this path, it should be the larger object. No other object should be as large as that of the planet. In fact, in the path of the Pluto, there is an object called as UB313, which was almost half the size of the Pluto. Therefore, it has not cleared the path. When it has not cleared the path, it should not be called as the planet. This is what the criteria. Come and write down the three criterias. Write down the three criterias as it is. In the year 2006, International Astronomical Union has given a new definition for the planet. New definition for the planet. Write down as it is. It should revolve around the sun. It should have enough mass so as to maintain the hydrostatic balance or hydrostatic equilibrium. It should have cleared its neighborhood. This Twiddle prompter is not coming online. No, that is not yet open. It's not working at all. You please check this one. These are the new conditions kept by IAU for any object to be called as a planet. With these, right from 2006, there are only 8 planets. Earlier, there were 9 planets. In fact, our Indian astronomers were, our Indian scholars were much ahead of the European scholars, especially in the case of astronomy, where our concept is called as Navagraha concept. Our Indian concept was called as Navagraha, where they have said that there are 9 planets. Probably in the future, something may happen. Again, they will be including the 9th planet. Okay? But as on today, how many planets are there? 8 planets are there. Okay? Now, after the brief understanding of the planets, now let us talk about the belt that is there between the Mars and the Jupiter. What is that belt that is there between the Mars and the Jupiter? Called as asteroid belt. What is the asteroid belt? Asteroid belt is such a rocky belt, rocky area, which is located between the planets like Mars and Jupiter. In fact, you can find some millions of rocky material. Suppose if this is the planet like Mars, if it is the planet like Jupiter, there are some trillions of rocky material like this. So many rocky material which are irregular in shape like this. Highly irregular in shape. And all these rocky materials are revolving around the sun as if they are the planets. What was the scenario? Earlier, in each and every orbit, now understand this one. In each and every orbit, what you are seeing right now is a planet which is a larger rocky material. This is the one. Another larger rocky material like Earth. Again, it is moving like this in this path. Once upon a time, during the formation of our solar system, all these paths are also having so many irregular shaped rocky material. There was no one such larger piece of rock like this. There are so many irregular rocky material in the path. Because of collision among each and every rocky material, one rocky material which has clubbed all the other pieces and made into a larger round ball-like structure, which is called as clearing the neighborhood. This is called as the clearing the neighborhood. Meaning what? A small rock, when it got collided, it has absorbed this rock into this one. When another rock got collided, again it was absorbed and started growing in size. As and when the collision was happening, it was keep on growing and finally form one larger round ball-like structure. This larger round ball-like structure is called as planet. This is how the planets has formed. Because of the process called as accretion. This is called as the process accretion. What do you mean by accretion? Nothing but collision and consumption. Whenever the other object, rocky material, whenever it gets collides, it will be consuming and it will be taking inside and making the size more. This is called as accretion process. This is how the planets, all the planets has formed. But in the case of this belt, even today, the rocks are present as individual rocky material. There is no clubbing of the other rocky pieces. What happened? Why this orbit is not having the planet? In fact, this is the orbit in the process of making the planet. But as on today, what is not there? One larger rocky material is not there. Different pieces of scattered rocky materials are there. What are these different pieces of scattered rocky materials are called as? They are called as asteroids. They are called as the asteroids. And the belt, as it is there in the form of a belt, is called as the asteroid belt. But the question remains. What is the question? Why all these rocks cannot convert into a planet? It's because one of the very important theories says that it's because of the gravitational attraction of the Jupiter on these rocks. The Jupiter is having such a greater gravitational attraction on these rocks, it never allow the rocks to club, to form one rocky material. There is an enormous gravitational pull of the planet because of this one, because of that larger pull, these pieces cannot get accreted. When they are unable to accrete, they are remaining as a smaller rocky pieces and got turned into solidified, strong rocky pieces. This is what the process. Because of having so many rocks, sometimes what happens, they collide among themselves because they are moving in the same path. Whenever they are moving in the same path and more pieces of rocks are there, definitely the collision will be happening. Whenever they get collided, these rocky pieces, let me remove all these things. These rocky pieces, they collide among themselves and they will be coming close to. They get deviate their path and they come towards the planets like this. Got the point? Whenever the rocky material is circulating around the sun, because of their irregular shapes, because of their movement of so many material, they collide among themselves, they get deviated their path and they come towards either Mercury or Venus or Mars or Earth or Jupiter or even to the sun. They go and hit all these material. The moment once their material comes and hits, what happens? These rocky pieces are so huge, sometimes there will be some kilometers together, like 100 kilometers, 200 kilometers. Sometimes they are so massive, they will be coming, or maybe simply of 100 meters, or half kilometer, or 1 kilometer of size. They may be of any shape, and if they get deviate their path and they come towards the earth, what happens? They will be coming with a speed of minimum of some thousands of kilometers per hour. Because of the collision that happens, the greater impact will be there. The moment once there is a greater impact, what happens? The life that is present, or if there is no life, the entire planet gets shakes. This is what happened some around some 65 million years back. What happened? One of the larger piece of rock which came from the asteroid belt and got collided towards the earth. The moment once it got collided, at that point of time, who were dominated on this planet earth? It was dinosaurs. When the dinosaurs were ruling, at that point of time, man was not there. When the collision happened, there was a greater impact, tremendous heat energy came out and perished all the life. All the life died. Slowly earth became cool, clouds formed, again there was rainfall, again the water drop stored on the land, again there was a unicellular organism, birth of conversion of the unicellular into multicellular organism, converted into complex cellular organism, and finally gave way for higher intellectual animal called as the human being. Had that impact has not happened, might be the entry of the human on this planet earth might be delayed. Whenever the new life form develops, definitely the new life form will be always higher intellectual life form. That is what it says. Earlier it was the dinosaurs. Because of the impact, what happened? The new animal called as the human beings came into picture. In the year 2013, come on, see this one. Recent, in the year 2013, on the day of a very, very important day. What is that important day in your February? 14, very good, okay. On that said day, what happened? Let us see this one. See, what happened in the recent past, I am giving. On that said day, the scientists, as they don't have any other work, they are looking at the space with the telescope. One of the scientists was enjoying seeing all the celestial bodies. All of a sudden, he is shocked by seeing one rocky material coming towards earth. Immediately the news was spread just like a wildfire. One rock is coming very close to earth. All the scientific community were given the information. All the telescopes of the world started staring at the rock. The information was sent to Barack Obama. At that point of time, he was the US president. Immediately, Obama said that don't inform this particular statement to the general public because there will be chaos and confusions. There will be chaos because, he says that today is the last day, whatever you want to do, you do. Tomorrow there won't be earth. If this is the case, what happens? Chaos will be there. Therefore, they didn't reveal the information. When the information was revealed, all the scientific community started in the world calculating what is the speed of the rock. They calculated the velocity of the rock. It was coming at around some 17,000 kilometers per hour. What was the velocity of that rock which got impacted the earth and the dinosaur got killed was just 8,000 kilometers per hour. It was 17,000 kilometers per hour. What is the size? Almost all 2.5 kilometers. That was just less than 1 kilometer of size of the rock. It is 2.5 kilometers of rock. It is coming towards earth. What the scientific community can calculate? The speed of the rock, the material with which it is made up of. They can calculate the angle, everything. But what they can't do is, they can't stop the rock. Some of the mathematicians calculate the shape of the rock and they said that as it is spinning and it is coming towards the earth, every chance is there, like this particular rock. Suppose if this is the rock, this rock may move towards the earth, definitely move towards the earth. It may go like this. It definitely enters the earth's atmosphere. Very narrowly it moves over the surface of the earth. This is what the prediction. And luckily on that fateful day, what happened? This rock came very close to the earth, went over Russia. It came in our atmosphere. It entered into the ionosphere. It entered into the mesosphere. When it entered into the mesosphere of our atmosphere, some of the rocky pieces of this larger rocky material got separated and fall at a city called as Chelyabinsk city. This is a city of Russia where some of the pieces got fallen and almost all some 30 houses got collapsed. This is what happened in the recent past. Meaning what you need to understand, when any rock is coming towards earth, as on today, we don't have any such technology to stop the rock. The people in the NASA, they say that yes, there is a technology which is called as the laser technology. If at all you are bombarding the laser continuously, it may change its path. It may. There is no guarantee. That is the only hope we are having right now. And how many are there? Some trillions of rocks are there. When we are discussing about this one, there may be collision and some of the rock may be coming towards earth. Many times it happens, but majority of the rocks are smaller in size. Majority of the rocks are smaller in size and therefore the impact on the earth's surface is very less. If the rock is of larger size, then what happens? All the life on the surface of the earth get perish. Because we already experienced such a extinction of life on the surface of the earth. Anything happen any point of time. This is called as the Chelyabinsk. This is called as the Chelyabinsk meteoroid. The incident called as the Chelyabinsk meteoroid incident that took place in the year 2013. Now, what are these words? Meteoroids, asteroids. We're talking about the asteroids. How comes there is another word called as meteoroid? Is it clear? Is this concept clear? This is what happened in the recent past, in the year 2013. One question is there for one of our friends. Come on. Yes, please repeat the question. Okay, see the question. What is the question? One question is why they didn't accreted to form the larger planet. It's because of the gravitational pull. When they are under the influence of the gravitational pull, how comes they deviate their path and comes towards the planet Earth? Got the point? That is the question. What is the question? As you said that it is under the influence of the gravitational pull of the Jupiter, if at all a rock, if it is getting bombarded, if it moves, it definitely has to move towards the Jupiter, not towards the other celestial bodies. It has to be only on the Jupiter, they need to fall. Got the point? This is the question. What is happening here? In fact, this is not one line, it's a range, it's a belt. Right? Whenever the collision takes place, the moment the collision takes place for the rock, it depends upon the shape of the rock for the direction. The rock will be moving in such a direction according to the shape. Wherever it got collided like this. If it get collides, it according to the shape, it will be moving. Like the best example, have you ever seen the instrument called as boomerang? The movement, once the energy is given for the boomerang, what happens? It goes all the way, and where it comes again? Because of the shape. On the same way, though it is under the influence of the gravitational pull, whenever there is a greater kick given by some other rocky material, what happens? Because of the shape, size, and the material that will be moving to the other side, it may come to any celestial body. It is not like it has to go only for the Jupiter. It may come towards the sun also. Many of the particles are coming towards the sun also. Because of the sun's energy, they get melted off. Whereas in the case of Earth, what happens? They come and fall on the Earth. Got the point? Now, after this one, let us talk about the objects like asteroids. What is the difference between the asteroid, meteoroid? Also, sometimes you will be coming across the objects like comets. And what is the current related news regarding the comet? One comet is going to come very close to our Earth on July 14, 2022. Are you following the newspaper? In the newspaper, it is given like one comet which has traveled all the way for some billions of kilometers towards the sun. And recently it has crossed the Mars. It was discovered in the year 2017. It discovered in the year 2017 when it was between Neptune and Uranus. When it was between Neptune and Uranus, when it was heading towards the sun, it was discovered in the year 2017. And therefore it is called as C 2017 K2. It's called as comet. C means what? Comet 2017 K2, popularly called as K2 comet. This popularly called as K2 comet. What it is doing? It was discovered in the year 2017 between Neptune and the Uranus, and it is heading towards the sun via our Earth. Got the point? Recently means what? A few days back, it has crossed the Mars. Now it is in the vicinity of our Earth. For watching this one, we need to have the telescope. We cannot watch just like that. It is moving at a greater speed, and at the same time, it is around some 2.5 million kilometers away from the Earth. That is what the comet. But what is a comet? What is an asteroid? What is a meteoroid? Let us understand. This is the current related one. You can see this one in the internet. Like, the comet, the people, whenever the comet passes very close to our Earth, they will be capturing these images and they will be posting in the internet. You can watch that one on 14th of, what is the day today? 9th. Another 4 days are there. Okay. Another 4 days, one visitor is there for the Earth. We need to say hi, hello for that visitor. That is what the comet. But what is the difference between the comet, difference between the asteroid and the meteoroid? Come on, let us see this one. Let me remove all these things. Yeah. Now, asteroids are the rocky material where the rocks can be very hard minerals. The rock composed of very hard minerals like maybe metallic minerals, over which you can find the covering of ice. Over which you can find the covering of ice. Why the ice cover has to be there? Because they are located far away. This is what the asteroid. They are irregular in shape. They are irregular in shape. They are not round ball-like structures. They are irregular. in shape. See, this condition of ice may be there, may not be there. Whenever we are talking about the ice, don't think that it is the ice of the water. What is ice for us? Always we believe that the water, whenever it gets condensed, it is called as ice. When we say ice here, don't believe that it is the water which got condensed over that rocky material. This is the ice of the gases like maybe methane, or maybe the gases like hydrogen, where it is covered with the strong solid material. The gases got converted into ice, and it is the ice that is present. Is it clear? That is what the asteroid composition is. These are the larger rocky material, not just the smaller rocky material. They are called as larger rocky material. Where they are present? They are present in the asteroid belt. They are there in the asteroid belt. This is what the asteroid. On collision, they get deviated their path. They can come in any direction. Sometimes they come towards the earth. When they come towards the earth, there will be a greater impact because of their velocity. Right? This is about the asteroid. Whereas meteoroid, see this one, meteoroid. Meteoroid are the smaller rocky fragmented pieces. Smaller fragmented pieces of asteroid. Pieces of asteroid. Whenever the asteroid gets fragmented, the pieces of this asteroid are called as meteoroids. They are smaller in size. When they are the pieces of asteroid, definitely the composition is one and the same, right? They are smaller in size, much smaller than that of the asteroids. These meteoroids can be again classified into two types. What are the two types? One is called as the meteor. Another one is called as meteorite. One is called as the meteor, another one is called as meteorite. What is the original spelling? It's called as meteoroid. The meteoroid can be of two types. One is called as meteor, another one is called as meteorite. What makes the difference? Let me write the flow chart like meteoroid is of two types. One is called as meteor, another one is called as meteorite. Right? What is the meaning? What the difference between the two pieces? If this is the Earth's surface, if this is the Earth's surface, what is there in the over the Earth's surface? Atmosphere is there. In the atmosphere, there is a layer called as mesosphere. We'll discuss all these things, like what is mean by mesosphere and all these things. In the Earth's atmosphere, this is we. This is we, right? Fine. This is the Earth's surface. This is the atmosphere. In the Earth's atmosphere, there is a layer of gases called as mesosphere. Now, whenever this small fragmented asteroid material deviates its path and fall into the Earth's atmosphere, where this material is called as meteoroid. This is called as meteoroid. Clear? Now, it enters into the Earth's atmosphere. Here in the mesosphere, what happens? Because of chemically active nature of the gases, this rocky material, not just the rocky material, any material which is falling onto the Earth's surface, it has to pass through the mesosphere. Because of chemical active nature of the mesosphere, this rocky material burns. It will be burning. Why it has to burn? Because of the chemical active nature of the gases, where they act as a very strong layer. This material which is piercing through the layer, because of the friction, they burn. The moment once they burn, we can see with our naked eye. Being staying here, we can see the material that is burning in the sky. For us, whatever that glow in the sky, we believe this as star. Is it clear? Because for the human, whatever that is glowing in the sky is a star. These people call this one as shooting stars. Why it is called as shooting star? Because the star appears to be falling. Where you people are well aware of this one. This is called as Turta Hua Tara. Got the point? Whenever the stars fall, what you will be doing? You will be praying, as you have seen in the movies, right? This is what the shooting star. In fact, that is not the star, that's a dust material. That's a rock material which got completely burned in the Earth's atmosphere. If it burns completely, because of its small size, if it burns completely, what will be falling here? What will be falling? This is the mesosphere. What will be falling? The ashes will be falling. If it burns completely, it is called as meteor. If the meteoroid burns completely in the mesosphere, it is called as meteor. Suppose if this meteoroid is somewhat larger in size and it started burning in the mesosphere, but it's not completely burned, a small piece of rock is left over as a remnant. A small piece is left over. It didn't burn completely. Whenever it didn't burn completely, it will be remaining as a solid rocky material. It falls directly here. Got the point? Let me shift this guy. Okay? It falls directly like this. It falls directly like this. Here. What is received here on the surface of the earth? The solid rocky material. This is called as meteorite. If the remnant is a solid material, it's called as a meteorite. If it is ash, it's called as meteor. Got the point? Whenever, now listen this one. Whenever these rocks fall, what is this one? This is a rock. Rocks are made up of minerals. What is a rock? The definition of the rock is the aggregation of different minerals. Many times, whenever any meteoroid reaches the Earth's surface, the scientists will be behind these rocks. They'll be running behind wherever they have fallen. They'll be going and they'll be checking. Because these are the rocky minerals which are present in the space. Might be sometimes they are not available on the Earth's surface. They are the unique type of material that will be received onto the Earth's surface. One of such material is called as iridium, which is very much useful for making the satellite parts or the spacecrafts or the space station. Whenever such a heavy material will fall, what happens to the land surface? The land surface get dented, deforms. When something falls on your car, what happens? The car will get dented, nothing but it gets depression. Same is the case with the land also. Whenever the larger rocky material is coming and falling all of a sudden, there will be a big depression. In that depression, over a period of time, because of the rainfall, the water gets accumulates. When the water gets accumulated, what that water body we call this one as? This is called as lake. Such lake is called as a crater lake. Such lakes are called as crater lakes. One of such a largest crater lake is present in India, formed because of the heat of the meteorite that is available, that is found in the state of Maharashtra. The name of the lake is called as the Lonar Lake. The Lonar Lake is a product of a meteorite. Now, are you clear with the meteorite, meteor and meteoroid? Is it clear? Come and write down all these things as it is. A small picture is also very much important for you to understand. Write down this one. Meteoroid can be of two types. One meteor and meteorite. One meteor, another one meteorite. Meteor and meteorite. Meteor and meteorite. Siding meteor. Siding meteor. What is meteor? When a meteoroid completely burns in the Earth's atmosphere, when the meteoroid completely burns in the Earth's atmosphere, when the meteoroid, meteoroid, meteoroid burns completely in the Earth's atmosphere and turns into ashes, it's called meteor. When the meteoroid completely burns in the Earth's atmosphere and turns into ashes, is called as meteor. Full stop. During burning, it is visible. During burning, it is visible to the naked eye. It is visible to the naked eye. And they are called as, what they are called as? Shooting stars. And they are called as shooting stars. You are well aware of all these things. Because, you know, the directors are so beautiful presenters. In many movies, you might have seen this one. When these two people are sitting calm and having great fun, and all of a sudden, it falls. Then the fellow will be praying, Bhagwan, pagli hai. Never seen this one? That is what the shooting star. Nothing but meteor. Got the point? Then, coming to meteoroid. Come on, give the heading as meteoroid. Sorry, meteorite. R-I-T. When a remnant is left over, when a remnant, R-E-M-A-N, remnant, meaning what? Whenever a remnant of meteoroid is left over as a residue material, when a remnant is left over as a residue, what is residue again? Nothing but remnant. Okay, same, one another two, same. As a residue matter, it reaches the Earth's surface. It reaches the Earth's surface. It reaches the Earth's surface to create a depression. To create a depression. Full stop. Such as solid rocks are called as meteorites. Such as solid rocks are called meteorites. And the depression is called as crater lake. Such a solid material is called as meteorite. And the depression is called a crater lake. Example, Lonar Lake of Maharashtra. Lonar Lake of Maharashtra is a crater lake. In fact, this is the largest crater lake of India. Recently, it was announced as a Ramsar wetland site. What is a Ramsar? What is a wetland? All these things you will be coming across in the environment. Is it clear? But try to know that there are certain land bodies which are called as wetlands. And they are enlisted in a convention called as Ramsar. Just get acquainted with the name. That's it. Don't go deep, because everything should be in a process. Slowly we can understand each and everything. Now you came across one wetland called as Ramsar Wetland Convention. Got the point? There is a meeting of the world countries where they have came to a conclusion that let we protect all the wetlands. What is a wetland? The land which is covered with the water body. These are called as wetland. Likewise, there are so many water bodies identified by the world organizations which are under the name called as Ramsar, R-A-M-S-A-R. Under the organization called as Ramsar. It's called as Ramsar wetland. One of the very important Ramsar wetland of India is a Lonar Lake. It's called as Lonar Lake. Is it clear? What is a crater lake? Example, Lonar Lake. Lonar Lake is a Ramsar wetland. Is it clear? What is Ramsar? All these things you will be coming across in the environment. But Try to get acquainted with the word called as Ramsar. Is it clear? Now, the last one, comets. What are these comets? After the meteoroid, then the last one called as comets. What are these comets? These comets are again the rocky material. Let me write like this here. Comets. Again, comets are rocky pieces like this. Suppose if these are rocky, irregular shaped, irregularly shaped rocky material, rocky pieces. They are irregularly shaped rocky pieces, but they are covered with huge quantity of ice. This is a solid rocky material covered with huge ice. So great size of the ice is there. Why such a great quantity of the ice is present? Because they are located not in the asteroid belt. Where they are found, suppose if this is the solar system, this is the sun, these are the 8 planets. Where they are found beyond this one like this, somewhere here. These are the comets. Is it clear? Where do you find asteroids? These are the asteroids. Where do you find the comets? These are the comets. Not present within the planetary system like within the Neptune. They are beyond the Neptune. These are the rocky pieces. These are the rocky pieces that are there. Irregularly shaped rocky pieces. As they are located far away from the sun, they are completely enveloped with the ice. Sometimes they will be coming like this, close to the sun, because they are also revolving around the sun. When they are revolving around the sun, they come close to the sun. When they come close to the sun, what happens? The sun is emitting so much of radiation. When such a great radiation is there, these ice, the ice that is present as an envelope around the rocky material, gets melted and appears just like a tail. All the ice goes back like this. Why the ice goes back? Because of the very high temperature. The rock that is facing the sun will be cleared of ice, but the material can hide behind the rock. And so all the comets will be having elongated tail. The best example, all you people are well aware of one comet where every 75 to 76 years it will be paying a visit to Earth. Halley comet. Right? In the year 2021, a new comet visited to Earth called as Neowise. A new comet visited Earth called as Neowise. They named it as Neowise. And right now in the year 2022, on July 14th, see, many things are happening on 14th. Why? No? Maybe that is a very important date for those also, okay? July 14th, okay? What happened? There is a new comet that is coming, paying a visit to our Earth, called as the comet K2. The name of the comet is called as K2. What is the full name? The full name is Comet 2017 K2. This is what the one. The full name popularly called as K2. Right? These are the comets. What are the comets? They are enveloped with ice, but as and when they come close to the sun, because of the very high energy emitted by the sun, the ice get melted and the ice will be acting as an elongated tail behind the rocky material, which is not directly facing the sun. Therefore, the comets will be having the tails. Is it clear? These are the very important celestial bodies that are there. Fine? The last point. Let me complete this one so that tomorrow we'll be entering into geomorphology. Right? Then, after the Neptune, see, this is the Neptune. After the Neptune, there is a belt called as Kuiper belt. Beyond Neptune, come on, write on the belt called as Kuiper belt, Q-U-I-P-E-R. Siding Kuiper belt. Beyond Neptune, there is a belt. Beyond Neptune means what? What is Neptune? Neptune is a planet. Beyond Neptune, there is a belt called as Kuiper belt. The objects like dwarf planets are present here. The objects like, what are the planets that you can find here? They are called as dwarf planets. Like, what are the dwarf planets you can find here? Like Pluto, UB313, and some other planets. The small planets that you can find there. There are so many tiny objects. Continue this one. You can find the dwarf planets. Along with the dwarf planets, there are so many tiny objects. And these objects are called as KBOs or TNOs. There are so many other smaller objects are there. They are called as KBOs or TNOs. What do you mean by KBOs? Nothing but Kuiper belt objects or trans-Neptunian objects. The trans-Neptunian objects. This is the Kuiper belt. What is the shape of the Kuiper belt? The shape of the Kuiper belt is donut shaped. It is the shape of a donut. It's a donut shaped belt. Donut, have you ever seen donut? Round ring, in between space is there. That is what the donut shape. It's a donut shaped object orbit. We call as the Kuiper belt. Within this Kuiper belt, you can find some dwarf planets along with some other objects, where these objects and the dwarf planets put together called as TNOs or the KBOs. Beyond Kuiper belt, continue the point. Beyond Kuiper belt, there is a cloud called as Oort cloud. Beyond Kuiper belt, there is a cloud called as the Oort cloud. There is a cloud called as the Oort cloud. OORT, Oort cloud. This is the most distinct region. This is the most distinct and distant area. DISTINT, distinct. DISTINCT, distinct. What do you mean by distinct? It's a peculiar, okay? It is the most distinct and the distant region. DISTANT, distant region of our solar system. Of our solar system. Full stop. It is believed to be spherical in shape. It is believed to be spherical in shape. Full stop. It is a big wall of, it is a big wall bubble, big wall bubble. It is a big wall bubble made up of icy particles. Icy particles of space debris. It's a big wall bubble, B-U-B-B-L-E, bubble. It is just like a bubble. Around the solar system, there is a last one called as the, in the periphery area, it's like a bubble one. It's a big wall of bubble made of icy particles of space debris. Icy particles of space debris, D-E-B-R-I-S, debris. The size of these debris varies from mountains. Meaning what? One huge rocky material is one mountain size. Just imagine. They vary from mountain size to a small boulder. To a small boulder. Varies from or ranges from mountain to a boulder. What do you mean by boulder? Boulder is nothing but small rocky material. Whereas a mountain is a huge. These are the space debris you can find in the Oort cloud. They range from anywhere between a boulder to a mountain, sometimes more than the size of the mountain. All these rocky materials are present in the Oort cloud. We need to explore this Oort cloud further. Till now, we came to know that yes, there is a Oort cloud. Around the solar system, there is a wall of bubble. The bubble wall is there, in which you can find the icy debris of space, like the mountains to boulders. This is about the Oort cloud and the entire solar system. In the next class, we'll start our geography. This is simply a brief introduction to the solar system and the universe and all these things. Right? Take care. See you in the next class with the heading called as geomorphology. Whatever we discussed till time is completely a brief introduction. From tomorrow on, means what, from the next class onwards, whatever we discuss should be very much strictly according to UPSC. Got the point? It is simply the introduction. Again, I am telling you very clearly, it is only the introduction for the universe, right? It is not the complete scenario. From the next class, that means what? The moment once you enter into geography, then we will be going in a very, very perfect manner, right? Take care, see you. We'll be meeting in the next class with the geomorphology. Bye-bye and Jai Hind.